Hi everybody and welcome. Today we're going to be talking about sequences. So we have two different types, and we're going to have two videos for each of those types. So for the first video, we're going to be talking about arithmetic sequences. So like arithmetic, but arithmetic for these sequences. And this is kind of like arithmetic. We're just kind of adding and subtracting numbers together. So we can officially define this as a sequence of numbers with a constant difference between terms. So what that's going to mean is if we have something like, let's say 9, 16, 23, 30 as our sequence, so just a string of numbers, an arithmetic sequence says that the difference between each of these terms is exactly the same. So between 9 and 16, 16 and 23, and 23 and 30. So let's see, is that true? Do we have exactly the same difference if we subtract these? And the answer is yes. The difference between all of these, if we put them together, is 7. And that is going to be something called our common difference. This is just in an arithmetic sequence. The difference between the terms. Or difference between, I should say, consecutive terms, or terms that are next to each other. So quite literally, we just take the number that's next to it and we just subtract it. And as long as that question is always the same answer, so if we always have 7, we're in good shape. That's what we're looking for. So in this case, common difference is 7. We label that as D. So common difference is labeled as D. So the last thing that we need to know for arithmetic sequences and common differences is an overall formula. So A subscript n equals A subscript 1 plus n minus 1 times D. And they're like, Mr. Reardon, what language are you speaking in? What is this? Well, we already know some of these things. So first thing, common difference is just D. So that's its place in the formula. If you subtract the numbers, that's where it belongs. N is just the number in the sequence. So if you're looking for term number 7, term number 2. So to be clear, this is term 1 right here. This is term 2. This is term 3. This is number 4. So if you're looking for any of these terms in the sequence, that is just literally the order that it is. So if you're looking for term 100, it'd be, all the way down there. So this is just saying the final answer of, let's say, term 7 is A subscript 7. So we're not actually multiplying 8 times 7, nothing like that. It's just a notation thing. Here, for A subscript 1, this is just the first term. So if we're looking at our sequence above, that's our first term. Literally the first number. So if you give a string of numbers, first number there, just pop it right in. So how do we do this? How do we fill this out? So let's do it for the one above. A to the n equals our first term, which is 9, plus n minus 1. We don't know n. And we know that D equals 7. That's it. So we're literally just basically every time we fill in this formula, we're just trying to plug in this and this. And what this allows us to do is solve for any of the numbers. So for example, I want us to know the second term. So A subscript 2. And we say this as our second term. Well, in this case, 9 plus 2 minus 1 times 7. And again, 2 because, again, it's our second term. So A subscript 2, 9 plus 2 minus 1 is 1, times 7. Or 9 plus 7. So our second term is 16. Is that true? Let's scroll back up. Boom. Second term right there is 16. So that's how we basically define an arithmetic sequence, is we just take whatever number we're looking for and plug in a value. And that works for anything. So if we wanted to find, let's say, the 12th term in this sequence, well, just replace that n with a 12. Everything else stays the same. So 9 plus 11 times 7, or 9 plus 77, and I'll get 86. So the 12th term in this sequence is 86. So that is one example of solving with arithmetic sequences. A second example that you might see is sometimes they'll give you some values, and they'll ask you to solve. So if they give you the 5th term in a sequence is 19, the common difference is 6, they might ask you, okay, set this up and solve. Well, a to the n equals the first term plus n minus 1 times d. So always, always, always go through and use what they give you. So in this case, they give us d, so let's plug that in right here. And secondly, we also know the 5th term. So 19 is our 5th term. So we just plug in, wherever we see the n, we plug in the 19. So in this case, we can go through and simplify. So we get 18 times 6 plus our first term equals 19. 18 times 6 is something that we would now want to, oh, I did the wrong thing. Let me rewind here a little bit. So everything here was good. So we still know d, which is 6. We still know 19 is that answer there. We still don't know our first term, but I made a mistake. We are given our 5th term. So here, for our 5th term, n equals 5. So we're going to replace n instead with the 5. Sorry about that, team. So again, be careful. Don't make the mistake that I just made, right? So this is saying this is our 5th term, but it's not equal to 5. So n does not equal 19, n equals 5 here for our 5th term. Some error analysis, so some good things and some bad things from that mistake. So hopefully that'll prevent you from making a similar mistake now that you can see it. Okay, so again, let's keep going, resetting here. So 19 equals our first term plus 5 minus 1 is 4 times 6. Multiply those together to get 24. And we'll keep going, subtract 24, and we'll get our first term equals negative 5. So with this information, we now know our first term, but we can also write our entire sequence. So a to the n minus 5 plus n minus 1 times our common difference of 6. So that is how we would define that arithmetic sequence. All right, so the kind of the big emphasis, the big idea for today is if we have